Hello guys. In the last video we reviewed how to use long division to divide whole numbers, and now we're going to extend that to dividing decimals using long division. So hopefully you noticed in the last video and then the assignment that followed that all of your answers divided equally, meaning there were no remainders in your answers. Unfortunately, life is not so nice, and oftentimes when we do long division problems we do get remainders. So that means that a number might not always have an equal number of pieces in each group. And so we're going to see that a lot today when we look at these division problems. Let's pretend for a moment that we have a bunch of flowers here, and we want to divide these flowers into, this should say groups of five, not five groups. We want to divide these flowers into groups of five. So if I start grouping these flowers into groups of five, there's five flowers, there's one group. Here's five flowers, here's another group. Here's five flowers, here's a third group. Here's five flowers, here's a fourth group, and you'll see that we have two remaining. So this means that we have four whole groups, okay, and two left over. So this means for this type of division problem, I would have a remainder, okay. I would have four and a little bit left over, but not enough to make five whole groups. And so the way we're going to represent that is with decimals. If I try to do the division problem, 22, which represents the number of flowers I had originally, divided by 5, which represents the number of flowers in each group, this is what happens. 5 can go into 22 four whole times. As we saw, we had four whole groups here. 4 times 5 is 20. And when I subtract, I get a remainder of 2. Now, when you first learned about long division, you probably learned to just write an R2 to represent 4 remainder 2, and you might have written your answers this way. We're going to learn how to write our remainders using decimals, so we're not going to use this R here. Okay, we're actually going to go a step further and figure out what decimal would our answer become. So the way I do that is 22 has an invisible decimal point in it. Its invisible decimal point is here directly to the right of that 2. And to the right of that 2, we can actually add in a 0, because we know that the whole number 22 is really equal to the number 22.0. And so if I extend this whole number by adding my decimal point and my 0, now I can bring down this 0, and I can keep on going in my long division. I can divide 5 into 20. Before I do that though, since I added a decimal point in here in my dividend, I want to be sure that I also put a decimal point in my quotient. I need to move this decimal point straight up, sort of like we do when we do addition and subtraction, so that it is to the right of my 4. So now I have a 4 point in my quotient, and now I'm going to take my 5 and divide it into 20. 5 will go into 20 4 whole times, and as we saw earlier, 4 times 5 is 20, and now when I subtract, I get 0. So now I'm done with this division problem. So the answer to this division problem does have a remainder, but we represent that remainder with a decimal, and this would be 4.4, or 4 4/10. Okay, so we're going to practice this now with a few examples down below. So number 1, I have 53.2 divided by 14. So the 14 is our divisor. It goes on the outside of our division house. And then the 53.2 is going to go on the inside of this division house. This time we're starting with a decimal on the inside of our division house. So all that means is that I'm going to move that decimal point straight up and make sure I line it up in my quotient as well. So this is where the decimal point will go in my quotient. So now that I have that decimal point added, now this just works like regular long division with whole numbers. I have a 2-digit number 14 that I'm going to attempt to divide into a 2-digit number 53. So let's use our estimation skills and think about how many whole times 14 would go into 53. Let's try 4 and see if that works. 14 times 4 is 56. So that's a little bit too large, so that tells me that 3 is going to be what I need to use. 14 goes into 14 times 3 is 42, so this will go in 3 whole times, and multiply there, I get my 42. We subtract 53 minus 42, and we get 11. And now we can bring down our 2, and now our job is to take 14 into 112. Use your estimation skills. Think about how many times 14 might go into 112. And if you said 8, you'd be correct. 14 actually goes into 112 8 times evenly. 14 times 8 is 112. So this 8 is going to go to the right of this decimal point I already put in here in my quotient to make this 3.8. And then when I multiply 8 times 14 and subtract, I get a 0 at the end, and we see that we're done. So the answer to this division problem is the quotient 3.8. Okay, number 2, we have 378 divided by 30. So 30 is going to go on the outside of the long division house. 378 will go on the inside. So we're going to start with the 2-digit number 30 and divide it into the 2-digit number 37. 30 will go into 37 one whole time. And so 1 times 30 is 30. When I subtract 37 minus 30, I get 7. And I can now bring down my 8. 30 will go into 78 2 whole times. 30 times 3 would be 90, so 2 whole times is what I can use here. 2 times 30 is 60. Subtract, and 78 minus 60 is 18. So I have a remainder for this problem. That means I need to keep going, and the way I keep going is by adding in a decimal point. So I add my decimal point to the right of the 8 in the dividend, and because I added the decimal point to the right of the 8, I need to also line up with my quotient and put a decimal point to the right of the 2. This is why lining up, again, your digits and your place value is important, and why using the grids can be really helpful. So I'm going to extend this long division house a little bit, and now that I've added this decimal point in after the 8, I'm also going to add in a 0 after the 8 to make this 378.0. And now bringing this down, I can divide 30 into 180. Well, 3 goes into 18 6 whole times, so 30 would go into 180 also 6 whole times. So I can put a 6 here to the right of my decimal point, and 6 times 30 is 180. So we subtract there, and we're done. And that means the answer to this division problem is 12.6. Okay, number 3, 186.3 divided by 27. 27 goes on the outside. And then the decimal 186.3 goes on the inside. So 27 is a 2-digit number. The first 2 digits in this the dividend are 18. I can't take 27 into 18, so I need to attempt to take 27 into 186. Okay, so let's use our estimation skills and think about how many times that might go in. 27 is close to 30. I know 30 goes into 186 whole times. So let's see if 27 might go into 186 6 whole times. 27 times 6 is 162. If we tried a 7, which is the next number up from 6, we would get a 189. So that means 6 is the most times that we can take 27 into 186. That 6 needs to go above the 6 here, okay, because we're taking it into the 3-digit number 186. And I also need to, I didn't do this before, line up my decimal points and make sure I put my decimal point in my quotient. So make sure it goes straight above the decimal point in the dividend. So this is going to be 6 point something for our answer. Okay, so 6 times 27, we figured out over here that's 162. Subtract, I get a 4 and a 2, so this is 24. And now I can bring down my 3. and see how many times 27 will go into 243. So 27 times 10 would be 270, so we could try 27 times 9 and see what we get there. And it just so happens 27 times 9 gives us exactly 243. So 9 is what we need to use. And when I multiply and do my subtraction, I can stop. So the answer to this division problem would be 6.9. Okay, one more division problem, and this is going to be a word problem. It says the area of the living room carpet is 262.5 square feet. If the width of the room is 21 feet, what is the length? So in order to do this problem, it helps to know a little bit about area. So anytime you're taking the area of a rectangle or a square, we hopefully know that you need to take the length times the width. Okay, the length times the width gives you the area of a rectangle or a square. Well, the area is 262.5 square feet, and we know that the width, which would be the shorter side, is 21 feet. So if the width times the length gives us the area, it makes sense to say that the area divided by the width would give us the length. And so that's what we need to do for this problem. We need to do a long division problem of the area 262.5 divided by 21. So 21 is going to go on the outside of our long division house. And then the dividend will be the area 262.5. There's a decimal in my dividend, so I'm going to bring that decimal up and line it up in my quotient. 21 is a two-digit number, and I can take 21 into the two-digit number 26 one whole time. 1 times 21 is 21. And when I subtract here, 26 minus 21 is 5. I can bring down my 2 now, and I can try taking 21 into 52. 21 will go into 52 two whole times. 2 times 21 is 42. And when I subtract here, I get 10. And I can bring down my 5, and now I need to take 21 into 105. Well, 20 will go into 105 times, so let's see what 21 times 5 would be. 21 times 5 is exactly 105, so that means I can put a 5 up here in my quotient. It's going to the right of my decimal points, so this means I have a 12.5 in my quotient. And when I multiply now and subtract, I get 0 at the end. So the answer to this division problem is 12.5, and because this was a word problem, we need to put some labels on this. We could say the length is 12.5, and we're measuring this in feet. 12.5 feet for the length. Now, if you're asking yourself, why is the length shorter than the width? There's a simple answer. Those words should have probably just been switched in the original problem. So either way, one side is 21 feet, the other side is 12.5 feet. If it bothers you that much, you can change this to length, and then you can change this to width. But either way, if you take 12.5 times 21, one side times the other side, you get 262.5 square feet. So don't let that part fool you too much. As long as you understand the long division, then you're good to go. If you had any questions over the long division, folks, make sure you have written those down so that you can ask those questions the next time you're in class. Until then, have a nice day. You are all wonderful people.